Welcome to the Explainer. So, we're just going to skip the agenda today because we're jumping right in. We're looking at functions, the foundational building blocks you're already intimately familiar with. But we're going to look at them through a highly relatable, very physical metaphor, the art of the dance.
Okay, let's dive into this. Have you ever tried to teach someone a complex dance routine step by agonizing step? I mean, really visualize this for a second. Imagine the sheer frustration of standing in front of a dance partner who literally has absolutely zero natural rhythm. You are painstakingly trying to teach them a routine completely from scratch. It's exhausting, right? Because you have to dictate every single micro movement of their body just to get them to move an inch.
Section 1, the left-right jump problem. Now, whether you're communicating with a human dancer on a physical ballroom floor or a digital machine processing logic on a motherboard, the foundational problem is exactly the same. Repetitive, granular instructions are a massive, agonizing drain on your time. Think about having to say out loud, Step 1, left foot. Step 2, right foot. Step 3, jump. And then imagine having to say that exact same sequence every single time you want your partner to do it over a full 3-minute song. Left foot, right foot, jump. Left foot, right foot, jump. It's incredibly tedious. Honestly, just reading those raw instructions out loud at that pace kind of drains the fun right out of the dance, doesn't it? It's slow, it's totally monotonous, and man, it is highly prone to human error.
Repeating every single granular step like that creates an exhausting bottleneck. In both dancing and programming, right? Repeating every little granular step every single time you want an action performed is just wildly inefficient. I mean, imagine if a software program had to be told how to calculate a simple math value step by step, literally thousands of times a second. Your entire computer system would grind to an absolute halt. There just simply has to be a better, smarter way to communicate these commands.
Section 2, meet the magic button. And this is exactly where we solve our repetitive instruction problem. We need a way to take all of that sheer exhaustion and compress it into a single, effortless, lightning-fast action. Now, what's really interesting about this slide is the visual proof of this efficiency. Look at how, instead of that tedious string of raw instructions on the left, we compress it all under one simple, catchy name on the right, the wiggle. We've essentially created a magic button. You push the button, you get the whole sequence.
So let's look at this exact quote directly from our source material. Instead of explaining left foot, right foot, jump every time, we named the whole thing the wiggle. See, by doing this, we've firmly anchored our dance move metaphor directly to the concept of a function. We've taken this complex sequence of physical actions and just wrapped them up in a neat little package with a nice label on it. Section 3, Mastering Modular Logic.
So it's time to step off the physical dance floor and actually look at the computer science theory behind what we just did. Because what seems like a simple trick to save your breath while dancing is actually a foundational, non-negotiable pillar of modern software engineering. Here's our formal definition. Modular logic is consolidating individual instructions into a single named function to simplify repetitive tasks. Now, as someone who follows programming, you use this literally every day. But thinking of it as the wiggle perfectly distills the absolute brilliance of what a function actually is, right? You're taking disparate steps, consolidating them, and naming them.
Let's move to this next part and see how this builds. By applying modular logic, a coder completely transforms their workflow in 3 distinct ways. First up, it consolidates individual instructions. This heavily cleans up their digital workspace. Second, it defines a complex sequence as a single, reusable unit. You build the logic once, and you can use it infinitely without rewriting a single thing. And third, it triggers the entire routine with a single, simple command.
Section 4, communicating with the machine.
I really want to completely reframe how you think about computer programming. Writing code isn't just about aggressively typing syntax onto a dark screen in a basement. It's about engaging in highly efficient, beautifully structured communication with a digital partner. And this brilliantly illustrates our ultimate goal. Let's say your digital dance partner's name is Cody. Instead of handing Cody a massive, heavy manual of microscopic steps every single time the music plays, you just say, wiggle, and Cody knows exactly what to do. It translates into perfect, immediate communication. You say one single word, and the machine executes the full, complex routine flawlessly.
Notice this dynamic separation of responsibilities here. On one side, the programmer intelligently names and groups code into these neat functions. On the other side, the machine stands by ready to execute that reusable unit on command. This separation of responsibilities allows for incredibly streamlined communication. The human gets to think in high-level concepts and ideas, and the machine handles the low-level, repetitive heavy lifting. It really is a perfect partnership.
Section 5, the power of reusable code. All right, let's bring all of these concepts together, from the dance floor to the motherboard, to emphasize the ultimate utility of functions in software development. Everything we've discussed culminates in this immense, practical power that shapes the digital world around us. So the crucial point is this. Functions serve as the ultimate tool for developers because they do three essential things simultaneously. One, they organize digital instructions so human beings can actually read, edit, and understand vast architectures of code. Two, they streamline repetitive tasks so computers can run them with blinding speed and efficiency. And three, they empower flawless communication between the creative human mind and the literal digital processor. Honestly, they're the invisible building blocks of every single application you use today.
Before we wrap up this explainer, I want to leave you with a final provocative thought to ponder. We've seen how modular logic works on a dance floor and inside a computer system. But take a step back and look at your own day. How else could modular thinking streamline the repetitive dances in our own daily lives? Are there routines, habits, or chores that you could group, name, and automate? Functions are undeniably a powerful coding concept, but if you look closely, they offer an even more powerful worldview for personal efficiency. Thanks so much for joining me on this explainer, and hey, keep looking for those magic buttons in everything you do.